This is Job Bedford here with his 15112 term project, the Blind Navigation Sonar Belt. It's a belt that helps you blindly navigate down a hallway using ultrasonic rangefinders and custom-made vibrators. The vibrators vibrate at a frequency proportional to the distance a person is away from walls. You have some on your right side as well as on your left side to signal when you are approaching a wall from either side of you. You have a knob here to set an interface mode and also to set the demo mode. I utilize Arduino to download my Python code onto here. I also use an H-bridge to help me use the speed controls. This is a pocket battery and it's on one big strip of Velcro so you can adjust it to the length you need. Alright, I'm going to run my interface. Run. And right here you have a beautiful splash screen. Project by Job Bedford, Sonar Belt Interface and Adjustable. Enjoy. You enter here, you have a couple buttons. You have stop, go, the motors, which control the motors, and then the sonar distance, which reads the distance from the sonar at that time whenever you hit sonar read or sonar read. You also have some adjustable settings to adjust the user's preference. You have the cutoff, which cuts off provides a maximum for the level of vibrations which you have. You have a range, which sets a maximum range that the sonar is going to sense, and then you have the levels, which are the different subset of vibrations. You don't want to get a raw PWM value for it's going to send up very touchy values. You want to break them down into categories or classify them into certain levels of frequency, which I do here. And you can adjust them to the user's preference. So, right now I'm about to test the sonar distance detection. You'll see these orange things go up with how close you are. So I press the button once. It starts at a value of 1. I am now holding my arm above it. Press it again. With this one again. Hold arm above it right now. I sonar read. It's too high. The bar went up because my hand was close enough to it, as you see here. Is the thing. As I put it closer to it and tell it to read, it sends a high value. As I go farther away from it, put the sensor right down here and click read, it sends a lower value. And that's how you adjust it. Now I'm going to set the motors just to test them out. I hit the start button. I can adjust how high I want the frequency to go. I can stop the motor. I can click on the other motor. I can start it. Increase the level of PWM signal that's being sent to it. And if you can see here, the motor's responding to it. I can also stop the motors at when I want. Now if you notice here, I made these vibrators with an offset to a regular fan motor so that when they spin at high frequencies it causes it to vibrate. And you just click on these setting sliders to adjust what setting you want. I personally prefer a cutoff value of about, say, as high as you can make it, about 247, and a range of about, say, 130. And levels I like to go up into 16. And then you just click on the handy dandy send button, and you're all set. And then it saves the values. You would just go into demo mode by turning the knob. Right here, it senses that I'm not there. Put my hand above it. I set the range too low, so I'm going to switch it again. I turn it back into interface mode. I stop it. And I increase the range now. I lower the vibration speed. and I click send again. I turn the knob. Now I'm going to see if it works. Alright then, and that is my turn project. Thank you.